Hello everybody, this video is to focus on the Florida Man project. This particular project was featured in 2017. What we have here is actually the first iteration of the Florida Man Gator head. This small prototype was used to test the electrical circuit. It was to make sure that the little WEMOS that was used in the process actually functioned with the LEDs. As you can see here, the second iteration actually came closer to the full production size. This way that the WEMOS no longer was at an angle, and we went ahead and added the silkscreen information on the back. JCon Systems was very helpful with the surface mount assembly of the LEDs and these little capacitors next to them. So as we look at this, these RGB LEDs are what we call neopixels. They're smart LEDs. They use a data stream to individually address each individual light and assign it a color based off of red, green, or blue. Up next to each LED is a supporting capacitor. For the sense, this capacitor is used to help protect the light from a jolt when they initially power on. The headers here are used with the WEMOS, and we can also see that the eyelet was used as a lanyard hang. That design allowed for mount point. The board standard FR4 1.6 millimeters with a green silk mask, standard most circuit boards as you would see. So the next step in the assembly was to place the headers on the board. These headers are kind of like Arduino headers, where they extend all the way through to allow stackable components. In fact, when this board is to be assembled for final use, you will actually stack the different devices. So we'll start with the WEMOS D1 Mini. It's an ESP8266 device. It on the back has a USB to serial converter for that USB port to communicate with the device and program it. And it simply just slides right in with the USB facing out towards the back of the head. That's pretty much it. It mounts right up on top, and it kind of sits over the cheek like that. And that is the mid interface to control the LEDs. This next board, or the bottom shield, was actually the battery shield. The ports are for the battery and USB, and it has a full charging circuit. Again, this is also by WEMOS. Now the pins are going to help you determine and align which direction it goes. They should match the writing on the top pins. So in this case, the USB ports are going to face the same direction out to the right, and once you align on the lower pins, you can see that they stack all together with the alligator head being placed in the middle of a 3-layer stack. This allows to charge, power, and light up the badge all at once. So the next part here is we'll go ahead and power up the device. You can actually plug the USB cable into both, but for now we'll at least plug it into the top WEMOS D1 mini board. And immediately the device powers on, and you can see a random light pattern triggered across the RGB LEDs. This pattern is to let you know that the device is on and functioning. It's almost like a screensaver without lighting up too many LEDs. There's a charge LED on the bottom. There's a green and a red. When the battery is plugged in, it will light up also red to show a charging status. So as you see here, the screensaver continues to operate and remind you that the badge is indeed on and functioning. There's also a reset button built in right there on the bottom that you can tap to reset the embedded circuit at any time. So each of these LEDs, again, is individually controlled, and we'll get to some of that functionality here once we understand how to actually hack the badge. So this brings us to what happens when you plug it into a computer. This serial terminal actually displays a message. You can press the reset button and it will rewrite information. So let's go ahead and use something called Esp Tool. This tool allows us to ultimately write or dump the firmware. So we select the port, the baud, and then we set the mode, so read flash, and we set an address range. In our case, it's about 4 megabytes. And then we'll go ahead and dump image as the output. Now this is going to take a while, and you can see that the blue light on top is lit up. After a little quick time lapse and speed ahead, we can see here that once we are done reading the memory from the chip, we have our dump image file. So let's go ahead and take a look at the header of the file. And this shows us some kind of useless information in our case. But we're not done here. What's, something that we can do to understand what this does? Let's take a look at the contents. Looks like a compiled binary of some sort, which indeed it is. This code has been written and it is extracted in its compiled form. Let's jump it in something like hexedit to take a look if we can see anything clearly. But this file is quite large, and that doesn't leave us with a lot of opportunity to read it from that perspective. Let's try something like a good old tool such as strings. This is a classic technique. And right away, we see the strings GatorNet and something that appears right next to it. I like to party, all lowercase, one word. Could this possibly be what is required to set up an access point? In fact, if you set up your own access point and use those credentials, the badge automatically connects to it because it is hard-coded to look for that network. We take the IP address that's displayed on the serial output and pop it into a browser. Immediately, we're given a web interface that allows us to actually change the colors of our lights on the front of the Gator head. You have a full spectrum of colors to choose a specific one, or we can choose from the modes. We also have brightness, speed, and other settings that allow you to kind of just have fun and play with the badge. So give it a try now that you understand the technique to extract the embedded credentials for the wireless access point. I hope this has been fun and you learned something new. And more videos to come. This is kind of the first of a series where I wanted to take an opportunity to share some of the awesome badges. So thanks for watching. I'll see you next time. And of course, what kind of YouTube video would this be? Without saying, go ahead and comment below if you actually have yourself one of the original Florida Man Gator heads, or if you learned something new from this video about working with the ESP8266.